Good afternoon, everyone. I hope you've enjoyed the conference so far. I'm definitely learning a lot of new things. I'm relatively new to platform engineering. And there's been a lot of really interesting talks today. Some of them have been quite in-depth. Some of them are a little bit easier to understand. And I don't know about you, but at this point in the day, my brain is tending to fade a little bit. So I'm going to make you a promise at this point. This isn't an in-depth technical talk. We'll have some technical details, but it's more of a story. Now, I'm a dad, 2 young kids, so storytelling is my favorite part of the day. And the story we're going to share today it's a little bit of a mystery story. It's a who, or rather, it's a what done it. Now, stories can start in different ways. If anybody's watching as I tested the clicker, you might have got a clue for the first one. So you've got your traditional approach. Once upon a time, as I say, both my boys love this one. But maybe you like a more modern approach. The older boy loves this one as well. But I'm going to guess that a lot of you, like myself and Ross, work in IT. And our stories tend to start slightly differently. Some poor engineer, after there's been an outage or a problem, pouring through code, logs, trying to solve a problem. And that's the kind of story that we're talking about today. But before we get into the details, I'm going to give you a brief introduction. So, my name is Simon Hanmer. I'm a member of the Community Builder program with Amazon, which is a program that they run to encourage people who are enthusiastic about their services to come and talk about them, write blogs, make videos. So there is definitely an Amazon slant to the story today. But I also work at a company called Global Logic. We are a product engineering company. And you tend not to see our name or our brands, but maybe as you were coming in this morning, you grabbed a sausage McMuffin or a Costa coffee and you use those big touch screens. We help develop those. When you leave tonight, you might head off, use a navigation app on your phone or in your car to get home. We've probably been involved in those as well. But we also have a traditional consultancy arm. We do digital transformation, and that's the part of the company that I work in. And that's really great as an engineer because I get to see lots of different problems and I get to meet interesting people, which is how I met Ross. Ross, if you want to introduce yourself.
Thanks, Simon. So I'm Ross Walker. I am an AWS infrastructure engineer at NatWest, and Simon was placed in my team as a coach, which was very timely for me because I was brand new to cloud, brand new to AWS, didn't know anything about it. That was about 2 years ago, and then the prior 6 years I worked in mainframe at NatWest. Banks still have mainframe, so 6 years on a black and green screen, AWS is rather refreshing. So here's our story, our use case. So we'd been tasked with building a monitoring application for capturing log data, which would process millions of events per day. So to do this, we had an S3 bucket. This is the existing infrastructure. With an S3 bucket, which all the logs would be captured in. So S3 in Amazon is just a data store, and it's got lots of good features, one of which is it captured events. But for our application, we needed the log data in a different specific location in the bucket. So what do we build? So we had our S3 bucket, and when we use these events, which is a very nice feature of them, they can be captured using EventBridge. EventBridge works on rules, so if this happens, then do this. So we configured an EventBridge rule to be triggered when a new object was written to our log bucket, and then from there we can directly invoke a Lambda. So Lambda in AWS is just like a script. In our case, it's a Python script. But as I said before, we're processing millions of records every day. So this would be millions of Lambda invocations. And as well as being really expensive, there is limits to the account, like how many concurrent Lambdas you can have running at one time. And I think we'd quickly reach this. So instead, we used a queue. SQS, again in Amazon, is just a simple queue service. It's just a messaging queue. And SQS is a feature that allows you to group up events into batches. So now we have a group of events from EventBridge, and we can pass them directly to Lambda to process. This makes the process a lot more efficient, and it saves on Lambda invocations. And then the Lambda processes them as usual and moves them to the correct location in the S3 bucket. Well, that was the plan. Simon, can you tell us what we saw?
Yes. Suffice to say, things didn't go entirely the way we expected. And this is where we're going to start to talk about some of the practices that we might use, either DevOps or site reliability engineers. We'd done all of the things that we wanted to do in test. We had automated testing in place. We had pipelines that were deploying properly. These were always working. And in test, 100% of the time, no problems. But when we got to prod, when we got to our live environments, we started to see problems. And obviously at this point, we wanted to start to understand what was happening. So there's a very small number of cases where this was failing, but it was time to start investigating and working out what was going wrong. And we've talked about the things that we need to look for in engineering. Observability is one of the big things that's going to help us. So Amazon has a tool called Log Insights. This lets us look into application logs. We can treat it as if it's a database. We can run queries against it. We can ask it to tell us information. These are all things that are really useful for us as engineers. And the first thing that we wanted to know was, what's the scale of our problem? How many transactions are we dealing with a day? And you can probably see down at the bottom there, we've got about 1.5 million transactions on a regular day. We can also use Log Insights to tell us about the errors that we're seeing. We can use that to search for the information that we can look at. We can count how many errors we're seeing. We can count what types of errors we're seeing. And in this case, we were seeing generally about 350 errors a day, 50 out of 1.5 million, tiny failure rate. Much less than you would expect if it was just a pure code problem. And the other strange thing was that we only ever saw one error, and no such key error. And if any of you have worked with S3 code, made API calls out to it, that means that when you're running your operation against those buckets, it can't find the object it's looking for. Now, that's a strange situation to be in. If you think about the architecture we'd built out, we only tried to process these records when we got that event coming through, telling us that an object had been uploaded and we wanted to look at it and move it. So we had this really strange situation where the system is telling us that we've got objects in that bucket, but when we come to look at them, they've disappeared. And this was really strange. Obviously, that's not what we expect. It was also strange because if we looked into the console or we use a CLI or any of the tools that we've got to monitor the system, we could see that those objects were there. Not a big surprise because we've seen the event. And if we took those details and put them into that batch manually, it always worked 100% of the time. So that ruled out those things that we've seen, maybe permissions or encryptions, those kind of problems that you might come across. So it obviously wasn't any of that. So the question is, what was happening? So Ross, sorry, my slide actually says do not hand to Ross at this point. So I will apologize. So a little bit of a history lesson. And this is where we're going to talk about things that we need to think about as engineers, not specifically to AWS, but we're going to use AWS as an example. So S3 was actually the second service now, as you can see the blog post up there. So it came out in 2006. Does anybody know which the first service was? No? It was SQS. So that message system, which sounds really strange, because why do you need a messaging system if you haven't got anything else to talk to? But you build on top of it. It was needed as the first stage for the other services. Now, you can see up there, S3, if you've used Amazon, you probably know this, but for those who haven't, it's an object store, it's highly available, it's very low latency, and it offers high data availability. And as it says there, the way it does that is it copies the data to multiple locations. Behind the scenes, you upload your object, Amazon receives it, and it copies it to the availability zones. We were talking about this earlier in the Gunnar's talk about chaos engineering. Those give us the resilience that we need to protect our data. But the problem is, when we're making that call out to query it, you can't control which availability zone you're going to take here. And that copying always takes a finite amount of time. It's always there. There's always a little bit of a delay. And if you're quick, you can actually hit an availability zone where the data isn't there yet, and that would give you that no such key error. You can't find the object. Now, this isn't a problem inherent in AWS, and this is where we start to talk about thinking about the problems in engineering. Some of you might have guessed the problem from that description. It's an issue called consistency, and it's existed in distributed systems for as long as they have existed. If you've got multiple places you can read data from, you can either have strong consistency, you know the data is going to be there, but it takes time, you have to wait. That has a cost in terms of latency. Or maybe you want to get things done sooner, and you'll take a small risk, in which case you can use eventual consistency. Things eventually all match up. And that's what was happening in this case, or so we thought. Now, consistency isn't just a problem about AWS. I'm going to guess that people here have used DNS. You make changes to a DNS record, update hosts, change the IP addresses. That takes time to make it out across the world. There are thousands of DNS servers. It takes a long time to update those. If you're in AWS, you've got DynamoDB. It uses the same approach for your data resilience, drops it in multiple availability zones. The advantage there is you can actually pay to get strong consistency. So at this point, we thought we'd solve what the problem was. We thought we knew what the issue is. Until, as we're doing our investigation, trying to gather evidence for this, we came across this. And the headline up there announces that Amazon now provides on S3 strong consistency. If you try and read some data after you've written it, it's guaranteed to be there. But that, obviously, then made us think, we've got this headline, this is telling us that this can't be the problem. So we carried on being good engineers, we did our log checking, we looked at metrics, we went through all the observability, all of the things that we're supposed to do. And I say we, mainly Ross. But the problem was, we'd made a mistake. And we'd read that headline. If you go into the details, you'll see S3 gets put lists, various operations, are now guaranteed to be strongly consistent. The problem is we weren't doing any of those. We were doing a copy, an atomic operation. It's not a read and a write. It's a single call. So that isn't in there. And when you've got a list like that, it's specific for a reason. This, after some time, back to what we were expecting. Now we know what the problem is. The question that we had to come across was, we're here today, so it's probably not a big surprise that we can. Ross, explain.
Thank you. Yeah, can we fix it? As you guessed, we're here, so we can fix it. So we said in our design, application design, we were using SQS and Lambda in pair, and it's this integration that handles this. So originally, in a batch, when a message in a batch fails, the whole batch was requeued to be reprocessed by the Lambda. But this means that you need to check if your record has been or has not been processed. And in our case, it's easy, because we can go into the console and check if our object's there. But in a whole batch of, say, 100 messages, it could just be one that's failed. So how do you work at the logic of just work at that one? But then in 2021, November, AWS brought a new feature with SQS and Lambda integration to handle this. So this is what Amazon called undifferentiated heavy lifting. It's when loads of people had one problem, so they brought a fix for it. So partial batch response for SQS and Lambda. It's when Lambda is smart enough to tell SQS exactly what events have failed, and only they are passed back to the queue to be reprocessed. So at this point, of S3 being eventually consistent, it's caught up, so the events will be processed again and work this time. So that's our story. I hope you enjoyed it. And like any good story, it should come with some lessons learned or some morals of the story. So here's our 3 takeaway morals. With serverless, don't just think about the code, think about the environment the code is running in. You need to consider consistency, network latency, or failures. Don't just skim read documentation, the devil's in the detail. We lost days from skim reading the S3 announcement being strongly consistent. If we'd read it properly, we would have known that's our issue straight away. And something that Amazon roll out at every conference is everything fails eventually. You need to consider how it can fail, what parts will fail, and design your system around that. Thank you very much for your time today. We're both around for the rest of today and tomorrow if you have any questions, but we'll take them now as well. And there's both our LinkedIn. I know everyone's loving a QR code today. Thank you.